What is spacetime curvature? What if gravity isn't really a force pulling objects together, but the result of space and time itself bending? This is the core idea behind spacetime curvature, one of the most fascinating concepts in modern physics. To understand spacetime curvature, we need to start with Albert Einstein's theory of general relativity. Before Einstein, gravity was explained by Isaac Newton as an invisible force acting between masses. Einstein proposed something radically different. Massive objects don't just exist in space and time, they actually shape them. Space-time is a four-dimensional fabric made of 3 dimensions of space and 1 of time. When a massive object like a planet, star, or black hole exists, it bends this fabric. The greater the mass, the deeper the curve. Objects moving nearby aren't being pulled in the traditional sense. Instead, they are simply following the natural paths created by this curvature. A common analogy is a stretched rubber sheet. If you place a heavy ball in the center, the sheet dips. Roll a smaller ball nearby, and it spirals inward, not because the big ball pulls it, but because the surface is curved. In reality, space-time works similarly, except in 4 dimensions rather than 2. This curvature explains why planets orbit stars, why time runs slower near massive objects, and why light bends when passing close to galaxies, a phenomenon known as gravitational lensing. Even time itself is affected. Clocks closer to strong gravitational fields tick more slowly than those farther away, a fact that has been experimentally confirmed and must be corrected for GPS satellites to work accurately. At the extreme end of space-time curvature are black holes, where space and time bend so intensely that not even light can escape. Near these objects, the rules of everyday experience completely break down. Space-time curvature shows us that the universe isn't a rigid stage where events happen. Instead, it's a dynamic, flexible structure, one that responds to mass and energy, shaping everything from the motion of planets to the flow of time itself. Understanding space-time curvature changes how we see reality, revealing a universe far stranger and more elegant than it first appears.